Hello, good morning students. So welcome back. Yesterday we have seen solid objects, those who have got polygonal surfaces, that is faces, they are called as polyhedrons, and if the faces are not polygonal, then they are called as non-polyhedron. Then we have seen what is meant by convex polyhedron and concave polyhedron. Then we have seen the regular polyhedron, that is which has got regular polygonal faces. Okay, and then we have studied about the pyramids and the prisms. Okay, and then we have verified a formula. Yes, it is called as Euler's formula. F plus V is equal to E plus 2. Now the last part of the topic, that is exercise 10.3, question 1. It says that, can a polyhedron have for its faces? So number 1, 3 triangles. So no, it cannot have 3 triangles for its faces, because a polyhedron have at least 4 faces. Now I have got all the triangles. See how many triangles are there? 1, 2, 3, 4. So at least 4 faces are always there for a polyhedron. So 3 triangles, it is not possible. Okay, so our answer, no. It cannot have 3 triangles for its faces, as a polyhedron has at least 4 faces. Okay, now next is 4 triangles. Can it have? Yes, it can have. It can have 4 triangles for its faces as triangular pyramid. Now only I have shown you. See here, 1, 2, 3, 4 faces. Okay, so yes, it can have 4 triangles as its faces as a triangular pyramid. So let us write down the answer. Okay, yes, it can have 4 triangles for its faces as a triangular pyramid. Okay, next. Now the third one, a square and 4 triangles. Yes, it can have a square and 4 triangles for its faces. A square based pyramid. Just I have here. This is the square. It is the base of that. And 4 triangles. 1, 2, 3, 4. So 4 triangles. So it can have a square and a 4 triangles for its faces as a square pyramid or pyramid with a square base. Okay, so let us write down the answer. Okay, now let us move to the next question, that is question number 2. Now see question 2. Is it possible to have a polyhedron with any given number of faces? They have given hint. think of a pyramid. Yes, it can be possible to have a polyhedron with any given number of faces. Okay, but if the number of faces is greater than or equal to 4, then only we can have polyhedron. Okay, because we have seen before this in question number 1, we cannot have 3 triangles, right? So at least 4 faces are there for a polyhedron. So definitely we can have a polyhedron with any given number of faces, but if and only if the number of faces is greater than or equal to 4, because a polyhedron always has at least 4 faces. Okay, so let us write the answer of this. So this is the answer. Yes, it is possible if the number of faces are greater than or equal to 4, because polyhedron has at least 4 faces, and they have said think of the triangular pyramid, and I have shown this triangular pyramid. How many faces? 1, 2, 3, 4. Okay, so 1, 2, 3, 4. There are 4 faces, minimum 4 faces. Okay, at least 4 faces. So if 4 faces are there, then it is possible. Less than 4, it is not possible. Okay, so now next, question number 3rd, you will do it as homework. Which are prisms among the following? I don't feel you will find it any difficulty in it. If your basics are clear about prisms and pyramids, so do that as homework. Now question number 4, how are prisms and cylinder alike? Now see, what are prisms? This is a prism, okay, and this is a cylinder. Now how they are alike? See here, in prisms, opposite faces, that is base and top, are congruent and they are parallel to each other. Same is the case with prisms. Base and top are congruent. Cylinders, base and top are congruent, okay, and they are parallel to each other. So moreover, a prism can be a cylinder if the number of sides goes on becoming larger and larger. Means there are 4 sides, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It goes on increasing. What happens? It will go on defining a circle, and finally this prism can be a cylinder. So prism can be a cylinder if the number of sides goes on becoming larger and larger and larger. Okay, and so prism and cylinders, they are alike. Okay, so let us write down the answer. So I have written the answer. A prism is a polyhedron whose base and top are congruent polygons and whose lateral faces are parallelogram in shape. Here the top and base of prism and of cylinder are congruent and parallel to each other, and a prism becomes a cylinder if the number of sides of its base becomes larger and larger. So as I have shown here, okay, so these are the bases and tops of cylinder. So you can see they are congruent and they are parallel. Same is the case with the prism. These are rectangular shape, base and top. Again they are congruent and they are parallel. Lateral faces, they are parallelogram. You know that. Okay. Now, so this prism can be a cylinder if this number of sides goes on increasing. Now these are 4 sides. Just see here. These are 5 sides. So if it goes on increasing the number of sides, finally it will become a circle. Because what is circle? Who has got infinite sides? Do you get it? Just do that. Go on increasing the sides. Finally you will get a position where you will feel, oh my God, it just looks like a circle. Okay. And so definitely this prism can finally become a cylinder. Okay. So next, second question. How are pyramids and cones alike? Okay. Now, I have got this cone, I have got this pyramid. Okay. Now, what you can tell? The lateral faces, they meet at a vertex here in pyramid. Okay. Same way, cone also, there is a vertex. The lateral faces, they meet at a vertex. Okay, no doubt. Here this lateral face is curved. Okay, now, and hence they are alike. Okay, moreover, pyramid can be a cylinder if the sides of the base becomes larger and larger. So it can become a cone. Okay, it can become a pyramid, can become a cone, not cylinder. It can become a cone. Okay, if its number of sides becomes larger and larger at the base. So this is 3 sides. You can see here. Now this is 4 sides. Okay, you can see here how the shape goes on changing. And this is 5 sides. See here, nearly looks like a cone. Do you get it? Nearly looks like a cone. Now if here there were 7 sides, 8 sides, you will feel that as if it is just like a cone. And so a pyramid can become a cone if the sides of its bases becomes larger and larger and larger. Okay, so what is this? What are the common things here? In pyramid, the lateral faces, they meet at a vertex, just like a cone. In cone also, the lateral faces, they meet at a vertex. So they have got, both of them, they have got common vertex at where the lateral faces, they meet. Secondly, a pyramid can become a cone if the number of sides of the base becomes larger and larger and larger. Okay, so let us write the answer. So this is the answer of question number 4.2. The pyramids and cones are alike because the lateral faces meet at a vertex. Also, a pyramid becomes a cone if the number of sides of its base becomes larger and larger. I have shown you. Now, question number 5. Is a square prism same as a cube? Explain. Okay. Now, square prism. Okay. This is a square prism. Why? Bases are squares. Now, the square prism can be a cube. Also, it can be a cuboid. Why? Because if the lateral faces of the prism are congruent to the base of the prism, square base of the prism, then it can be a cube. See here. These are the lateral faces. These are congruent to the base and the top. And hence this is a cube. Else, if the lateral faces are not congruent to the base, then it is what? A cuboid. Then it is what? A cuboid. You can see here. This is a cuboid here. These are rectangular. These are not square. So if all the lateral faces are square, just like the base, then it can be a cube. Or else, if they are not so, it can be a cuboid. Hence what we can say, a square prism can be a cube or a cuboid. It cannot be compulsory cube. Okay, depending if the lateral faces, are congruent to the base, then it can be a cube. If the lateral faces are not congruent to the cube base, then it cannot be a cube. It will be a cuboid. Okay, let us write down the answer. So this is the answer. A square prism has a square as its base. Thus, base and top of a square prism are square. I have shown you. If its other faces or lateral faces are also congruent to the base, then it is same as cube. That means lateral faces are also square. And if its lateral faces are rectangular, then it is same as cuboid. So a square prism is not same only as a cube, but as cuboid also. Do you get it? So let's move to the next question, that is question number 6. Now question 6. verify Euler's formula for these solids. So second figure I am going to do it. I have drawn already the figure and I am going to show it here. So this is a cuboid and this is a square prism. Okay, so if I place it here, see the same figure you can see on the board. Okay, now first what we will do, we will fix the number of faces, then we will find out the edges and then we will find out the vertices. See here, so first is faces, 1, 2, 3, 4, 5, 6, 7, 8, okay, 9. How many faces? 9. Now let us go to the vertices. 1, 2, 3, 4, 5, 6, 7, 8 and 1, 9. So 9 vertices. Now edges. How many edges? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And see here, I have forgotten this. We will count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How many edges? 16 edges. Okay. So you can see I have joined this and I have prepared this. So various shapes, combinations are possible. Okay. Now Euler's formula. What is Euler's formula? So using Euler's formula, F plus V is equal to E plus 2. That is the Euler's formula. So we will first find out LHS. F plus V. So that is 9 plus 9 is equal to 18. And RHS. What is RHS? E plus 2. That is 16 plus 2. That is 18. So what do you get? Oh yes, LHS is equal to RHS. Hence, Euler's formula is verified, right? Do you understand? Okay, hence Euler's formula is verified. Okay, first one you are supposed to do in the same way. Now question number 7. Now question 7, using Euler's formula, find the unknown. So from that second one I am going to do. First and third, it is homework for you. So second one, F is equal to 5, that is number of faces is 5. Vertices we need to find out and edges are given 9. Okay, so here we are supposed to use the Euler's formula to find vertices. So using Euler's formula, we get F plus V is equal to E plus 2. Okay, now I know F. What is F? 5. V I don't know. E is 9. So 9 plus 2. 9 plus 2? Oh yes, 11. So 5 plus V is equal to 11. Bring this 5 to this side. It will become, definitely, it will become subtraction. So V is equal to 11 minus 5. And 11 minus 5? Yes, 6. Okay, so how many vertices are there? 6. Therefore, there are 6 vertices. Okay, so first and third you will do. Now the last question of this topic, question number 8. Now see question number 8, what it is, can a polyhedron have 10 faces, 20 edges and 15 vertices? You have to find it out. Okay, so what you have to do? Definitely you have to verify the Euler's formula. So use the Euler's formula and verify it whether LHS is equal to RHS. If it is not so, then, and if it is so, then. If it is so, then it can have. If it is not so, then it cannot have. Okay, so let us do it. Using Euler's formula. what is Euler's formula? Oh yes, F plus V is equal to E plus 2. Right. Now LHS. What is that? F plus V. What is F? 10. V 15. Right? So F plus V, 10 plus 15. How much? Oh my God, 25. RHS. RHS E plus 2. What is E? 20. 20 plus 2. 20 plus 2, 22. Now, is LHS is equal to RHS? LHS is 25. RHS is 22. Are they equal? No. So, therefore, LHS is not equal to RHS. So, what can you say? No, it cannot have. So, therefore, no. My final answer, no. A polyhedron cannot have cannot have 10 faces, 20 vertices and 20 edges. 20 edges and 15 vertices. Okay, so no, a polyhedron cannot have 10 faces, 20 edges and 15 vertices. How we did? We verified Euler's law. So that is easy. Okay, so dear students, I hope whatever we have studied in this topic you have understood. If you have got any difficulty, definitely you can call me and ask your doubts and clear them. Okay, and so your today's homework, I'll write the homework on the board. So your homework is exercise 10.3, question 3rd, 1, 2, 3, 4. Question 6, number 1, and question 7, 1 and 3. So this topic is finished here. Definitely try to solve these examples, and today we'll stop here and we'll meet in our next period. Till then, goodbye. Thank you.